So we're just going to be working on getting ready for the final exam today. We have no new material to cover, so today and Monday we'll just be working, and I'll be taking questions, can work together, ask each other questions. It's a great time to use the resource of your classmates if you don't have time to get together outside of class to study. So some general stuff about the final exam. It's going to focus on big ideas, big concepts from the course, not obscure stuff. And the big ideas are, the three big ideas from the course: limit. That's sort of the definition of what makes a calculus problem. A calculus problem is that it involves some kind of a limit. A derivative, derivatives, and integrals. So those are the three big things that we talked about over the semester. For limits, you need to know what a limit is, be able to compute a limit if I give you an equation or a formula or a graph, be able to find a limit using L'Hopital's rule, and be able to interpret limits and think about limits in terms of continuity and differentiability of a function, right? Because limits were part of the definition of being continuous. Limit from the left has to equal the limit from the right, has to equal the value of the function. And then derivatives, this is what we spent most of our time with this semester, was dealing with derivatives. You need to know what it is. I probably won't ask you to compute it using the limit definition, but you should know how it's defined. You should know how it's defined graphically, numerically, and algebraically. So graphically, what is a derivative? Slope of a tangent line, yep. Numerically, it would be a difference quotient, right? F of b minus f of a over b minus a, and you let b and a get closer together. And then algebraic would be the limit. Be able to interpret a derivative. Think about what its units are, what it measures in various contextual kinds of problems. Compute derivatives using various rules. We've learned a lot of them. And then be able to use a derivative to solve all these special kinds of problems that we've learned how to do: optimization problems, related rates problems, find extrema, and inflection points. And then the last big topic that we've just spent the last 4 classes since the last test talking about is integrals. You need to know what a definite integral is, interpret a definite integral in terms of what are its units, what is it measuring, compute a definite integral from a graph or a table using your you will not have a graphing calculator in the final, so I won't ask you to like type in and come up with the value of an integral on a calculator. You might have to do a Riemann sum, yeah, but if I ask you to do a Riemann sum on a test, I'll ask you to use like 2 intervals, right? So you won't have to do a ton of calculation. You need to know the fundamental theorem of calculus, how to compute the average value of a function. That was the example about the Tiffany lamp, right? Something like that, but nothing else from 5.4. So it's a 2-hour test. It's not much longer than any of our other exams, maybe just a teeny little bit longer. The date is Wednesday, the 17th. Wednesday, 12/17, and you can take it anytime from 8 to 12. Two hours, you know, don't get here any later than 10. But 8 to 12 will be fine. Anytime in there. Any questions about the final? So your homework for the next couple of classes is just to study. This is project 7. If you haven't handed that in yet, it's due at the final exam. All you have to do is write some stuff on it and you get 100 project grade. I won't even read it until after I do your grades, so you just have to hand something in. And you have a study guide for the final exam. I just want to point out from the study guide that you will be able to use 3 two-sided sheets of notes for the final. That way you can bring, hopefully you saved the 3 that you made for the first 3 tests, and then just add, there's not very much material since then, so you can just squeeze it in the margin or something if you need to add anything else. Or feel free to make 3 brand new ones, whichever you prefer. Yes, they can be typed. They can be written or typed just as long as they're created by you and not photocopied from some other source. You can also use the derivatives reference sheet and the guidelines for related rates problems.
Those count separately?
They count separately, yeah. In addition to your 3 sheets that you create. Yeah. You can use only a scientific calculator, not a graphing calculator. I will have some to lend if you don't have one of your own. And again, you should be able to work with the big ideas of limits, derivatives, and integrals. Okay. And there's a list of things that you should be able to do, so you can kind of use this as a checklist as you're studying. And then you got a bunch of practice problems.